I wonder if you could touch on a little bit about sexual dimorphism, specifically as it pertains to human beings.
So if a woman makes eye contact on the street or smiles, men will automatically think that this woman has an interest in them, whereas.
How do you think we could get more people interested in biology?
So they should learn something very early on about our nature. Who are we? We are part of the animal kingdom, and we fit into one of these categories that taxonomists have created to essentially classify all life forms. You would not believe how many college students, even at a top-notch university such as the one that I'm teaching at, are still confused about the difference between brain and mind. So the best thing that explains why humans are sometimes aggressive and sometimes peaceful is cost-benefit analysis. It's all related to competition.
I'm here today with Dr. Dario Maestripieri from the University of Chicago. Dario, thank you for joining me.
My pleasure.
I'd like to start just in kind of broad general terms. Maybe we could start with how you first became interested in the field of biology.
So I was lucky as a child to come across a book written by Konrad Lorenz, who was one of the founding fathers of ethology, the discipline that studies animal behavior from a biological perspective. And it was a book called On Aggression. And the book is about human aggressive behavior, and it provides some explanations in terms of how other animals engage in aggression as a form of competition, and how some of the explanations that we can use for animals can also be applied to human behavior. And I was struck by the approach in that book. So the idea that you can understand human behavior in the context of nature, evolution, biology, and other animals. So I thought that that was the approach that I wanted to take. Not the most direct approach to study humans through the discipline of psychology, but taking a more indirect approach. So study biology, study life first, study evolution, so the process that produced life on Earth. Then study how evolution has shaped the behavior of other animals, particularly the behavior of our closest relatives, non-human primates. And then finally, make the final step from animals to humans. So that's the approach that I took.
How old were you when you found this book?
I might have been 10 or 11. My parents subscribed to a book club. They never read any of the books, but this book was one of the first to come in the mail. And I read it, and I thought, this is it. This is what I want to do. I want to become a professor. I want to do research, and I want to study human behavior from a comparative and an evolutionary perspective.
Yeah. It's interesting how a singular event like that can really shape your life.
Yeah, again, it wasn't the content of the book, the facts. These days, I teach a class in which I say that everything written in that book is basically wrong. But I like the approach. I also liked the enthusiasm that the author had for these things. So reading the book, you could tell that the author loved the animals that he studied, loved biology, and felt that he was doing something important. He didn't write this book just to entertain people, to make money. He really thought that he was explaining the way things are. And so I thought the approach was very powerful. Clearly, it's a book written in the 1960s or 70s, so now it's a bit dated. Now I use it in a history of science class. But I like the approach. I think the approach is still very valid. This more indirect approach where you start from the study of life, you understand what life is, you understand the process that has shaped life on Earth, and then you take the comparative approach and see how humans relate to the other animals. I was thinking about this the other day, that the study of other animals, and particularly primate behavior, is basically the building block for understanding human behavior. It's very foundational. I mean, one could just skip ahead and just study psychology, but it would be equivalent to just going straight to college without going through elementary school, middle school, and high school. So I feel that for me, studying biology, evolution, and then animal behavior was basically taking things step by step. So to me, studying primate behavior was foundational. It was the ABC for the study of human behavior, which is very complex and sophisticated. And at some point, you have to specialize. But it's good to have those building blocks at the beginning.
Because you studied rhesus macaques for many, many years.
Yeah, most of my career as a primatologist, which officially ended about 10 years ago, I happened to study rhesus macaques in different locations, first in Europe, then in the States, and for the final few years in Puerto Rico.
And what are some of the takeaways from your 25 years of studying rhesus macaques?
So at a very basic level, we need to be aware that the humans are a species of primates. So we share some fundamental aspects of our behavior with other primates. Not all primates, but those that are most closely related to humans, such as circumpedestrian monkeys, apes. One thing that we share with most primates is our obsession with power, with dominance, with hierarchies. Not all animals have hierarchies, but those that live in groups, that live in complex societies, such as many species of monkeys and apes and humans, they do have hierarchies. And so studying this phenomenon in primates was very helpful. But also it was helpful to study primates as individuals, to understand how individuals survive in a society, to understand how relationships are necessary for survival in a complex social setting, to understand how individuals navigate these relationships and complex social dynamics. So I observed monkeys for decades, maybe more than 25 years. And I can tell you that I never ever got bored, not a single day. Every day I saw new interesting things that I had not observed previously. So it was a journey of discovery. And if I stopped at some point, was not because I lost interest, but because I felt that I had learned almost anything that I wanted to learn. So I had answers to some basic questions that I started out with. I'm sure there are many more interesting things that could be discovered, but for me, I was eager to make the next step and to start doing human research.
What would you say to people that think that humans' kind of thirst for power is more culturally, a cultural artifact, if you will?
So many different behavioral scientists have been interested in this topic of power hierarchies, sociologists, political scientists, economists, psychologists. I have to say that this is one of the topics for which there is more confusion in academia. So people have very different theories as to what power is, where it comes from, why it's so important in human lives, and I don't think much of many of these theories. I do believe that biology and economics also provide a very powerful way to understand why these hierarchies exist and why power is so important. In a nutshell, hierarchies are a byproduct of competition. So competition is a fact of life, particularly for organisms that live in complex societies. So we compete with other members of our society as well as with members of other groups. So competition can be very harsh. So members of the same species can kill each other over access to resources. So hierarchies have evolved as a way to reduce the harmful effect of competition. So to avoid that animals of the same species, members of the same group and same society, to avoid that they kill each other over access to food or mates or territories, essentially. So hierarchies settle disagreements, contests over resources without the spilling of too much blood. So hierarchies are something that has evolved repeatedly in many different organisms. So the hierarchies that you see in humans are not necessarily similar to the hierarchies that we see in other mammals or birds or other vertebrates. So they have evolved many times in socially living animals. And there is a type of models in game theory. Game theory is a branch of economics, which essentially explains why dominance and therefore hierarchies evolve. And that has to do with the way you can resolve a dispute without always fighting or always negotiating. Okay? So the way you do that, you exchange signals. If there's two individuals who want the same thing and they don't want to negotiate because negotiating is stressful, they don't want to fight because fighting is harmful, they can simply exchange signals. So one says to the other, I'm willing to fight all the way to get what I want. And the other will say, I'm not so willing. So you can have it. So they settled their dispute essentially by communicating their motivation to fight or their motivation to let the other take. And this is the basis for power. This is the basic for hierarchies. We call, at the level of the dyad, at the level of the two individuals, we call this dominance. But you can think of a group as composed of many dyads. So each dyad has a dominance relationship. and altogether they add up to form a hierarchy.
Is it possible to have a human society without a hierarchy?
Yes, and in theory, it would be possible to have a human society without aggression and violence. So one of the things that Konrad Lorenz was wrong about was his thought that aggression was inevitable. It was a necessary evil. The original title for that book was The So-Called Evil. So, and also he was a little mistaken in his belief that aggression was existed for the good of the species. We don't think along those terms anymore. So things evolve not for the good of the species, but for the benefit of individuals. So to say that something has a biological basis or a natural basis does not mean to say that it is good or that it is inevitable or necessary. Philosophers call this the naturalistic fallacy, the idea to think that if something is natural, biological in its origin, it's necessarily good. We know that in nature there is no good and bad. And we know that there are many things that happen in nature, such as infanticide, which we don't approve of. So we as society decide what's morally and socially acceptable. So I tell my students that human beings are neither aggressive nor peaceful. We are potentially aggressive. So we're able to live peacefully in the company of many strangers, as many of us do, but we're also able to express very intense levels of violence. So the best thing that explains why humans are sometimes aggressive and sometimes peaceful is cost-benefit analysis. It's all related to competition. So back to your question, if you eliminated competition, for example, if there's abundance of resources, if there's food, mates, territories, money, enough for everybody, you would eliminate competition and you would eliminate hierarchies and power. But that's obviously impossible. There's never enough for everybody. But what you see is that when competition is intense, aggression and violence are more intense and hierarchies are more rigid. So hierarchies matter more. Power is more important. If competition is less intense, and there are many situations in nature where competition is very low intensity, and then you see that these societies are relaxed in terms of their hierarchical structure. And so there's even some human groups in which hierarchies are not as important. So hunter-gatherers, they're known for being more egalitarian. Why? Because it's their lifestyle. It doesn't make a lot of sense. It's not cost-effective to defend resources because they have a nomadic lifestyle. They go around with their sheep or with their herd from place to place. They cannot effectively monopolize their resources. So whenever humans and other animals are able to access very valuable resources that can be effectively monopolized, which means they can exclude other individuals and groups from these resources, so it pays to be aggressive and violent if necessary. So one thing that has made a difference in our evolution as a species was the agricultural revolution. So agriculture made it possible for people to essentially accumulate wealth by owning land, and that exacerbated differences, inequalities between people who own land and other resources and people who didn't. And so as a result of that, wars started. And most wars in human history have been about land and resources. If humans had maintained a nomadic lifestyle, if they had just been hunter-gatherers, we would be a fairly more peaceful species.
I wonder if you could touch on a little bit about sexual dimorphism, specifically as it pertains to human beings. Why are males generally larger than females?
Sexual dimorphism could evolve for a couple of different reasons. One is sexual selection, particularly the process by which members of one sex compete with each other for access to members of the other sex. For example, in many species, males compete for other males to have access to females as mating partners. This process of intrasexual competition can favor the evolution of larger male size. So males can become larger in evolutionary time to become better competitor against other males. But there's also an ecological explanation. In some species that live in groups, females who live in the company of other females tolerate the presence of some males within these groups because these males assume the role of protectors. So they defend these females from predators. In that situation, it's possible that males have evolved a larger body size to become more effective at protecting females from predators. In some cases, it's hard to disentangle the relative contribution of sexual selection, so within sex competition, versus this more ecological explanation. Because in these species, males both compete with other males for sexual purposes and fight against predators to protect females. We know, though, that sexual selection is very important because in species that have polygynous mating systems, in which males mate with multiple females, males are generally larger, stronger, and more aggressive than females. Whereas in species that are monogamous, in which one male mates with one female and vice versa, typically there is no dimorphism in body size or appearances. So there are some monogamous species in which males and females are virtually identical in size and physical appearance. So in humans, there is a moderate degree of sexual dimorphism because for most of our evolutionary history, we were a mildly polygynous species. So polygyny was a fairly common mating system. So human males mated with more than one female. In some human society, this is still a common form of mating. But the human species has been evolving and changing, not just biologically, but also culturally. And so at some point, monogamy became more prevalent as a mating system for reasons having to do with child development. So it's beneficial to both males and females to invest in children, and that in turn requires monogamy. But still, humans have maintained a moderate degree of sexual dimorphism. And according to some scholars, true monogamy does not exist. So whenever we say, oh, humans are monogamous species, well, there's a few exceptions.
Mm-hmm. What are your thoughts on the theory that the dimorphism is due to nutrient restrictions, like males getting access to the best food or larger quantities of food, and females have had more restricted access to these type of foods?
Well, I'm not too familiar with this explanation, but that seems more an explanation in terms of mechanism. Mm-hmm. So what is the mechanism by which males get to be larger? So obviously they need to eat more nutrient foods and in larger amounts. But this doesn't provide an ultimate explanation. So what is the ultimate ecological or evolutionary explanation why males need to have a larger size? So obviously being larger is more expensive. You need to support a larger body size. So why? If there is no benefit, it makes no sense, right? So the two explanations are not incompatible. We know that in species in which the dimorphism in size and strength is reversed, there are a few species of mammals in which females are slightly larger and more aggressive than males and more dominant. For example, spotted hyenas and some species of lemurs in Madagascar. We know that one explanation for that is that females need to have priority of access to food because of their reproductive needs. In other words, if females didn't have this priority of access to food, they wouldn't be able to sustain pregnancy and lactation, which are very expensive in these environments. And so essentially they need to be dominant over males. So they need to eat first and the best quality food. And that has presumably led to the evolution of female dominance in these species. But ultimately, so that the reason must be either ecological, as in the case of predation, or related to reproduction, having to do with competition for mating, or in the case of the lemurs and the hyenas, the constraints of reproduction, the fact that reproduction for females is very energetically expensive and females need to have access to good food, particularly during gestation and lactation, otherwise they won't be able to reproduce and everybody will lose. Obviously, it would make no sense for males to inseminate females if these females cannot carry their pregnancy to term and raise healthy babies. So it's in males' own interests in these species to defer to females, to let females be dominant, because obviously they want to reproduce, they want to have offspring.
Could you talk a little bit about your journey from evolutionary biology to where it is now, with all of your interdisciplinary interests?
As I said, I started studying biology because I thought that to have an understanding of human behavior, I had to put humans in the context of life on Earth, other life forms, and evolution as the process that has shaped life on Earth as we see it. So then I thought that studying other animals that were similar to humans would give me some insight into some basic aspects of human nature. The simple fact is that some components of human nature, some components of the human mind and human behavior have a very ancient history. So I tell my students that humans did not invent anything in the domain of fear, pain, sexual attraction, sexual pleasure, basic social processes. All these things have been around for longer periods than human evolutionary history. So to understand these processes, you can study almost any types of vertebrate life. And so essentially, I feel that I gained a good, solid understanding of why, for example, humans are a gregarious species, a social species. What are the pros and the cons of living in complex societies? Why we have the mating system that we do? What is the importance of parenting and child development? The importance of competition and cooperation. These are all fundamental aspects of our lives, which I think need to be understood from a broad biological evolutionary perspective. But then at some point, you become aware that there's limitations in terms of what you can learn from other animal species. I mean, monkeys and apes are very complex. But as we say about human evolution, at some point, humans filled a new niche, the cognitive niche. So at some point, we began using our minds to be successful, both in terms of our survival and our reproductive success. So to really fully understand humans, at some point, you need to understand the human mind. Also, the extent to which humans are different from one another. So the extent to which individual difference matter in the human species, I think, is unprecedented on this planet. So if you had asked me, what is the most striking things you've learned about human behavior, human nature? Now I've been doing human research for 25 years. I would say individual differences. So that's, I found, the most striking. So obviously there is a human nature that we all share, but individual differences are so striking. And so I felt that there was only so much I could learn about human individual differences from non-human animals. So the single greatest discovery that I did since I started doing human research has been the field of personality psychology. So there is personality in animals. So I even published a book about animal personality, but it's a much simpler, less sophisticated concept. So individual differences exist, and there's some ecological reason for why they are maintained, because the environment is ecologically diverse. So sometimes different individuals exploit different niches in their environment. But the extent to which personality differences are diversified in humans really has no parallel in humans. So I studied personality psychology on my own a few years ago, and that has changed my outlook on human behavior. So the past few years I've been studying and doing research on human personality differences, and I feel that I've gained a much more comprehensive understanding of human beings. At some point, studying the human mind and human behavior, so how the mind is expressed through human behavior, was not enough for me. I also wanted to explore more direct products of the mind. So for example, ideas. So I became interested in human ideas and the history of human ideas. So that's become one of my fields of research, the history of ideas. And also I become interested in what some people would call artifacts. So humans are great at producing complex artifacts in the forms of art, books, literature, but also architecture, furniture, anything. And there's a lot you can learn, human nature, but also about human ideas and human history through the study of artifacts. And so in recent years, I've become interested in history of art, literature, music, poetry, you name it. In my mind, it's all interconnected. Mm-hmm. So in my mind, even these artifacts that seem to be very distant and very detached from our own animal, primate, human nature are in themselves an ultimate product of this nature. So it's all interconnected. But the extent to which humans can build on their cognitive capacity, we have a unique ability to think in terms of abstract concepts. I don't believe that animals have this ability. For example, we can think about concepts such as fairness or love or justice. These are things that we cannot see, smell, or touch, and yet they exist, and they have a very important role in our lives. And the importance that mental states have, for example, in regulating human behavior. Think about intentionality, for example. It makes a huge difference to us whether the behavior of other people is intentional or not intentional. The entire human legal system is based on this concept of whether, for example, criminal behavior is intentional or not. Well, intentionality is a mental state. It only exists in the minds of people. So animals, it seems, are not capable of explaining the behavior of other individuals on the basis of these mental states, intentionality. So they don't understand intentions, desires, needs, and so on and so forth. So this is incredible. And it shows that once humans conquer this cognitive niche, it gives rise to all kinds of ways in which we can interact with each other, we can negotiate life in human societies, and the way we understand and explain our own behavior and the behavior of others.
Why is biology important? Why should anyone care about biology?
Because we're part of biology. We are biological organisms that have evolved from other biological organisms. So there is an issue of origins. So where do we come from? Biology has the answer. There is an ontological issue, an issue of existence. Who are we? Biology has the answers. And also potentially where we're going. Potentially biology or cultural evolution have the answers. So if you have existential questions, if you have historical questions, if you're interested in the present or the past or the future, biology has something to say about that. But biology is often misunderstood by people. Some people think that if you are a biologist or if you tend to favor biological explanations of behavior, then you are a determinist. So they think that you think that biology determines our behavior. So one thing that I tell my students is that biology is not destiny. We have some control over our lives. There's a reason why we no longer use terms such as innate or instinctive, because these terms imply that some aspects of behavior are 100% biologically, genetically inherited. And we know that there's no such thing. Any behavior is in part the result of genes and in part the result of environment. It's the product of an interaction. So it makes no sense to speak of instinctive or innate behavior. Instead, the expressions I use, is that in some cases, in some domains, we have biological predispositions or tendencies. So this is the equivalent of nudges. So economists think about nudging people in certain directions, so encouraging people, pushing slightly people in a certain direction to make certain decisions. That's what evolution has done. In some cases, the nudges are not so subtle. So for matters, they're crucial to our survival. So we have nudges built in our system that make sure that we avoid things that are dangerous or harmful. So for example, we have a pain system in our head, a pleasure system, the fear system, motivational, emotional systems. They're there in place to make sure that we don't do things that are harmful to ourselves, and to make sure that we're motivated to be attracted to other individuals for social or sexual purposes, because that's what's necessary for survival and reproduction. So these biological propensities and tendencies, if they do exist, they're not deterministic. So they can be controlled and they can be suppressed. So we might have an urge in some situations to be aggressive and violent, but of course we can control that urge. So biology is not destiny. There's nothing deterministic in biology. And also biological laws, if any such thing exists, are not deterministic like in physics. They are probabilistic. So the laws of physics are deterministic, meaning that they don't allow for any exception. If you were to discover a single exception to the law of gravity, I think that would be a problem for the law of gravity. If there is a single organism on this planet that defies the laws of gravity, that will be a problem. Anything in biology instead is probabilistic. So natural selection produces adaptation. That doesn't mean that every individual is fully adapted or that the behavior of an organism is adaptive all the time. We do plenty of things on a day-to-day basis that are not adaptive. that might be self-defeating, self-harmful, but that's not a contradiction to the idea that much of our behavior is the product of natural selection. So it's important to understand that everything in biology is probabilistic. So there are exceptions, and we're not at the mercy of evolution or biology or genes or anything like that.
How do you think we could get more people interested in biology?
I think school education is crucial. I think children need to learn from the very beginning that humans are another animal species, that we fit within the animal kingdom, so they should learn some taxonomic classification. So they should learn that humans have are a particular type of primates. So they should be able to classify human beings within the general animal kingdom. So they should learn something very early on about our nature. Who are we? We are part of the animal kingdom, and we fit into one of these categories that taxonomists have created to essentially classify all life forms. Then they should learn something about our past, our origins, where we come from. So when I was a kid, again, I was told that there were mysteries in life, that the human life itself was a mystery, that human behavior was a mystery, that religion had a lot of mysteries. And so part of the reason why I was drawn to biology is because I did not find this concept of mystery very appealing. I thought, maybe people say it's a mystery when they're ignorant about it and they haven't done enough to dig under the surface. So to me, saying that something was a mystery was essentially an encouragement to do research and to discover what was behind this mystery. So I've concluded there's not many mysteries. I mean, don't get me wrong, life is fascinating and it's a never-ending process of discovery. But we don't have to call it mysterious. So we don't have to say that life is mysterious or some answers will never be found. So human origins, human evolution are not a mystery. So Darwin actually figured it all out. So we owe it to him that we're able to understand where humans came from and what was the process involved in our evolution. So children need to understand that. They need to be explained also religion and culture as parts that are related, maybe not directly, more indirectly, about human evolutionary history. They need to understand where our brain comes from. They need to be told, for example, that the brain and the mind are basically the same thing. You would not believe how many college students, even at a top-notch university such as the one that I teach at, are still confused about the difference between brain and mind. Almost on the first day of class, I asked the students to give me a definition of the brain, which pretty much everybody can do, and then to give me a definition of the mind. And I get as many different definitions as many students I have in the class. And at the end of the class, after I let them talk and speculate about what the mind is, I tell them it's the same thing as the brain. The reason why we have two different terms is historical. And the reason is that back in the past, 200 or 300 years ago, people did not know that our thoughts came from our brain. And so that's why they had two different terms. One to indicate the structure, the organ that resides in our skull, in our head, and one to indicate thinking, ideas, so on and so forth. They didn't know they were the same thing. Now we do. We still use two different terms, which is very confusing. And people should not wait until they're in college and take my class to discover that brain and mind are the same thing. We should teach this in elementary school.
What is something that you've learned over the course of your career in science that has informed something specific in your own life?
Interesting question. I think I have a good answer for that. I've been surprised, and still am on a daily basis, how poorly people understand themselves and other people. So many of us, and I don't blame anybody for that, have no familiarity with this concept of personality. So personality traits is something that we all have, and we all fit into certain categories of particular configurations of personality traits. So we could all be more or less classified into one category of personality. Most people do not know what their category of personality is, and they have no idea what personality traits other people have. And these might be people that are their family members, their parents, their brothers and sisters, and even people that they married. I've met friends who have been married for decades and have no idea why their spouse behaves in a particular way until I ask them, can you describe the behavior of your husband or wife to me? And then I figure out what kind of personality they have. And then I explain that to my friends. Listen, your husband or wife behaves in a particular way because they have this personality. You may or may not be compatible with that particular personality, given your own personality. And I'm surprised how little knowledge of these concepts people have. So they do not understand themselves very much, and they don't understand others very much. So to me, studying personality allowed me kind of later in my life to understand what kind of people my parents were, friends, romantic partners, my own children. Also, I was, for most of my life, very attached to this idea that I was a self-made man, that I had invested a lot in this process of growth, of maturation, that I had struggled to accept certain facts and ideas and concepts and beliefs about my life. I thought that was all part of a process of growth until I read a chapter in a book that described exactly my personality. So I discovered I was just a manifestation of a particular type, and probably my education had not mattered as much. So I become convinced that somewhere there is an article or a chapter in a book that explains the way every one of us is. So if people don't know this because they haven't read that paper or article yet. So keep looking until you find a paper that describes exactly who you are. And that, I think, will be an eye-opener.
Do you think people intentionally avoid looking for that?
Yes. So I started writing a book about the cost and benefits of the knowledge and ignorance. The tentative title of this book is Knowledge is Power, but Ignorance is Bliss. So yes, in some cases, there is a benefit in not knowing who we really are, or to have a better view of ourselves. I mean, there are studies that show this, that people tend to have a nicer view of ourselves, and that we tend to have slightly distorted views of what other people think. So for example, if people are asked to rate how others like them from 1 to 10, they think, oh, others rate me as a 7, whereas it turns out that others rate you as a 4. So we always have a better, more optimistic view of what other people think, which is good.
Why do you think that occurs?
So there are two aspects of how the mind works that have been shaped by natural and sexual selection. One is to deal with issues of survival. So a lot of the machinery that we have in our mind is there to help us avoid dangers and things that are harmful to survive. So in that domain, humans are best described as very cautious. So some of these predispositions that we have make us cautious with regard to potential dangers and risks. So for example, exposure to pathogens, germs, bacteria, virus, we're very cautious. For other things that are more related to reproduction, we're very entrepreneurial. So, and the issue is easy to understand. If you want to survive, you can just sit still in your own apartment and never get out. As long as you have food delivered to you by Amazon, you will do just fine. If you want to reproduce, instead, that strategy is not going to work so well. You have to go out and take risks and sell yourself, so to speak. So in the domain of anything related to reproduction, our minds are designed so that we are risk takers. We're more willing to start new ventures without knowing, or in some cases, ignoring what the chances are of success. It is well known that, for example, that half the marriages in the US end up in divorce. Or when you start a venture like a new business, a new company or a restaurant, there is a very high chance of failure. So a large proportion of new businesses, new ventures fail. Well, people don't know this, and even if they knew, they would not believe it, because otherwise nobody would get married or nobody would ever start a new business. So we have this bias in our minds. They make us think, oh, this happens to other people, but my marriage will work. My venture will work. My company will not fail. So in this domain, we're not cautious, we're optimistic. So we overestimate our chances of success because this is what you need for reproduction. If you're not an optimist, you will never reproduce. So, and particularly males. Males are overly optimistic about their chances of success in the mating domain. There's studies that show that men, for example, heterosexual men, overestimate the sexual interest that women have in themselves. So if a woman makes eye contact on the street or smiles, men will automatically think that this woman has an interest in them, whereas it's not the case.
Do males also overestimate their likability in terms of other people?
This is something that both men and women do. So yes, this is a built-in bias that we all think that we're more likable than we really are. Then there's some of us who have even greatest predispositions to think that we're very likable. So one thing that I've become very interested in recent years has been narcissism. So why do narcissists exist? It is not a pathology, in my opinion. It is actually possibly a predisposition for success. So narcissists tend to believe that everybody likes them, that they will never fail, that they will be able to accomplish anything that they set out to pursue. And in some cases, they are able to succeed in that. It's as if they have an extra gear. It's as if they have a more powerful engine. So narcissism, in my opinion, is best viewed as a high-cost, high-benefit strategy that not everybody can afford. It's essentially equivalent to driving a Ferrari on the expressway. So you can go a lot faster than other drivers, and you can get to your final destination a lot more quickly, but the risk of getting into a crash is much higher. And not everybody can afford to drive a Ferrari. But if you can, then it makes sense. So to explain narcissism, we have to think that we're not all born the same. And it's not even a matter of birth. It's also a matter of early environment. So some of us are born healthy, some are born not so healthy, some of us are born small, some are born large, some are born good looking, some are born less good looking, some are born into families that have power and wealth, and others are not. This is something that we call embodied capital. It's as if when we start our lives, we're given a certain bank account with a certain amount of money, but we don't all have the same capital in the bank. So some of us are born with a larger capital. So those people, it's as if they're born a step ahead. And so I tend to believe that narcissism is something that is given to people who have higher capital to allow them to go faster. So if you're born good looking, powerful, and wealthy, you can afford to drive sort of in the fast lane. But you can also, crash and burn and burn your Ferrari. But again, there's studies that shows that people who are narcissistic tend to be people who are wealthy or good looking or anything like that. So, but not everybody's born that way. And some people, even if they're offered the opportunity to be wealthy and successful, they will not take it. So not everybody's born to be a leader. Some of us are born to be followers, and that's fine. That's how evolution works. Not everybody in a society can be a leader, and not everybody can be a follower. There's a need for both leaders and followers.
But most of the population would be considered followers then, correct? Or?
Yes, exactly. So the people who become leaders are very ambitious, very motivated. Sometimes they have an inflated view of themselves. They have an outgrown optimism about their ability to succeed. And most people are not like that. So most people are average. So they have some degree of ambition and industriousness, some degree of motivation, but not at the extreme level that you need to become the president of the United States or to become the CEO of a company or the general of an army. So people who achieve these positions of power, of wealth, of fame, they have skills that are in some cases above average, including intelligence or social skills, but they also have motivation and drive that is way above average. So not everybody has that.
So what are some of the most pressing questions in your field that you're most excited about to pursue or look into?
Well, I don't have a single field anymore. I have multiple fields, and what's pressing and interesting to me might not be pressing or interesting to other people. So over the years, my interests have become broader and broader. The kinds of questions that I become interested in have become broader. And that's why I've moved a little bit outside of science, because scientists, especially these days, tend to be fairly narrowly focused on a particular area or even a question. And that's the way it has to be in most fields. You need to be highly specialized to be effective and successful in your field. I'm less interested in that. So I'm interested in science as an approach that allow people to find answers to certain questions. And the questions that interest me are broader and broader. So I'm interested in, how minds produce ideas, how ideas shape our lives, how they shape human societies, history. So I've become interested in studying patterns in history. Why is it that certain societies seem to go through certain cycles? For example, they change political systems. Why civilizations rise and fall? What's behind that? But also at an individual level, I'm interested in what makes certain individuals exceptional. There are certain questions that we still know very little about. So, for example, questions about intelligence, cognitive capacity, questions of social skills. Obviously, there are some of us who do things in different ways, right? You could argue that Silicon Valley was established by a particular subgroup of human beings that are interested in technology or computers or math. And obviously, they've been very successful. But they like to be in the company of other people like them. So we don't understand, for example, whether you're born that way or whether you become like that. So we don't understand how evolution is currently shaping some aspects of the human mind. Some people are beginning to ask the questions, what are human beings going to look like a few centuries into the future? And how does AI or other new technology are going to interact with their own biology to shape future human beings? I think also until recently we had a very poor understanding of human psychopathology. So we had a very traditional, in my opinion, limited view of what mental health issues were, what psychopathology was. My interest in psychopathology relates to my interest in human nature. See, so in my opinion, true pathology exists, but other forms of mental functioning that we consider pathological, in reality represent simply extreme versions of normal variation in psychological behavioral functioning. So many human psychological or behavioral traits have a normal distribution in a population, which means that most individuals have intermediate values of those traits. Many behavioral scientists, many psychologists have for decades concentrated on the middle of the curve. So we have studied the average, and we haven't really paid any attention to the tails of the distribution. So we either think that those are statistical outliers, so they're not interesting, or we call them pathological. In reality, they're not. So I think in the future, we're going to pay more attention to individuals who seem to have rare characteristics, and which in the past were considered pathological. But sometimes we consider something pathological if there is a lack of fit between an individual's and their environment. So all you need is to understand what kind of environment is necessary for that individual to thrive. And I think this opens up a lot of interesting avenues, not just for science, but also for education. I think we do disservice to kids if we put them all through the same system of education. So we put all kids through the same type of curriculum. We make them learn all the same things, and it's obvious that is necessary to some extent. But it's also true that not every child is the same as everybody else. So it's possible that some children would need a more specialized type of education. And so we need to understand who these children are and what will be optimal for them. So it's possible that in the future there will be different types of school that are informed by research in psychology, which are essentially tailored to slightly different kinds of kids, for example, that learn in different ways. So for example, some of the research I've done in recent years has been about people who like to get up very early in the morning and go to bed early, and people instead who like to sleep in the morning, get up very late and go to bed very late. These are fairly stable individual differences which appear relatively early in adolescence and which impact a lot of aspects of our lives and functioning, including, for example, cognitive performance. So the idea is that if you test a child, say on a math test at school, at 8:30 in the morning, it'll make a big difference whether that child likes to get up very early, so at 5:30, because at 8:30 he'll be at top cognitive functioning. Whereas if you test a child who likes to sleep until noon or 1, he's not or she's going to perform as well, because these people perform at peak later. Some of us, for example, write books at midnight, others at 5 in the morning. But by treating all children the same way and by testing them, for example, all at the same time, we're benefiting others and handicapping others. So the education system has not taken these differences into account, but there's hope and potential for the future for these basic understandings about human nature to be incorporated into our education.
Thank you, Dario. Appreciate the time.
You're welcome. It was a pleasure.